Hello everyone, my name is Kristina Zhelatkova and I'm one of the engineers working on the new plugin-based designs and deployments model for Aria Automation. I know that this new plugin model includes a lot of new concepts, so I hope this tutorial helps you get up to speed with everything new faster so that you can start enjoying the new capabilities and the flexibility it gives you. Public cloud providers like AWS, GCP, and so on support a lot of different resources you can create and manage, and a lot of different settings or properties you can configure for each resource. So the goal of the new plugin model is to make Aria Automation keep up with the ever-evolving public cloud providers easily, while at the same time providing its useful features like allocation for the newly added resource types. In this way, you'll be able to get the new public cloud provider resources or resource properties quicker in Aria Automation. Currently, in order to provide this, Aria Automation is integrated with a new plugin-based technology that allows us to expand the support for the wide variety of cloud resources. In this tutorial, we're going to go through several scenarios. Feel free to log into your Aria Automation environment and try them out with me. We'll begin by creating a simple cloud template containing only a basic plugin-based AWS instance, and we'll continue evolving this cloud template step by step. We'll create a new version of the cloud template on each step and deploy it. We'll go back to each version in the end of the tutorial to summarize everything we did together. After we deploy the basic AWS instance, we'll gradually work on configuring it dynamically using the new location helpers. We'll start with the computer location helper, then we'll add flavor and image helpers, and finally we'll leverage the network allocation. Then we'll reuse all of our allocation helpers to configure another plugin-based AWS instance. We'll also create and attach a plugin-based AWS volume to one of the instances, and we'll use the same computer location helper to configure our volume. Finally, we'll see that we can also leverage the new allocation mechanism for resources based on other technologies, not only on the new plugin-based technology. More specifically, we'll dynamically configure a resource from a type that already existed before this new feature, which will be a KMS key in our case, and we'll reuse the computer location helper for this purpose to make sure the key ends up in the same place as our volume so that we can use it to encrypt the volume. So let's get started. Here's my Aria Automation environment, which I'll use for this tutorial. Before I proceed with creating the first version of my cloud template, I want to show you one of the big benefits that come with the new plugin model. This is a comparison between the properties supported by the standard AWS instance we have in Aria Automation, I mean the resource type that we had even before the new plugin model, and the properties supported by the new plugin-based AWS instance, which comes with the new plugin model. You can easily see that there are a lot more things that you can configure for the new resource type. It should be basically everything the cloud provider, in this case AWS, allows you to configure. Of course, there is no one-to-one mapping between the properties on the left and the properties on the right, so the comparison is not entirely fair, but still the new resource type provides a lot more flexibility. For example, you can specify some CPU options to optimize your instance for specific workloads or business needs. You can define the number of CPU cores and the threads per core. Or you can use some special AWS features, for example, to provide optimal Amazon EBS input-output performance for your instance by setting this EBS optimized property to true. Or you can enable your instance for hibernation. Or if you have deep learning inference workloads, you can accelerate them by attaching elastic inference accelerators to your instances. So if AWS offers something specific that is very useful for your use cases, the new plugin-based resources should allow you to use it. Okay, let's create our cloud template. Before I add my instance, I want to show you the other main benefit of the new plugin model. Here's a list of the plugin-based GCP resources we are currently working on. You can see there are a lot of different resources here, and this list will probably grow even more. The resources you're seeing here are still under development at the time I'm recording this tutorial, but I wanted to highlight the variety of the plugin-based resources. So let's start configuring our AWS instance. The only prerequisites here are to create an AWS Cloud account in Aria Automation and a project. Nothing special that you need to use for this plugin-based instance. In the first version of our cloud template, we'll configure every property statically. Let's keep it simple for now. I'll add values for the required properties first. I'll name my instance. Let's place the instance in US East 1 region. This is the Aria Automation Cloud account from which the credentials for authenticating with AWS are taken. And I'll use this image ID for my instance. And this is all you need to configure in order to deploy a resource from this new resource type. It's that easy. Now let's add some optional configurations, just to show you a few. But again, this is not necessary. You can go ahead and deploy it like this if you want to. Let's add a specific availability zone in which the instance will be created. Let's define the instance type to be T2 small. And let's connect our instance to a specific network. I want to know that the subnet ID I'm using here is the actual ID of the subnet from AWS itself. Let me quickly show you. It's this subnet from AWS. And the same goes for the image ID here. It's the one from AWS. And that's it for now. Really simple and straightforward. So if you're trying this out for the first time, start from the easiest thing. Don't begin with the last version of the cloud template we're going to create as part of this tutorial. Just go ahead and deploy this initial version. You can even stay for some time on this scenario, play around with the properties and get more confident before you proceed with the more advanced configurations we're going to do here. Let's create the first version of our template and deploy it. This will take a minute or two to deploy, so let's fast forward until it's done. Great, we have successfully created our first plugin-based resource. And as you saw, it was really fast and easy. I can see the ID of my resource here. So I can copy it, go to AWS, and find my instance by its ID. I can open it and verify that all configurations were applied to it. So let's go back to our cloud template and make it a bit more interesting. As you probably know, we can configure resources using cloud template inputs so that we can choose different values each time we deploy a cloud template. The same goes for the new plugin-based resources. So let's create a cloud template input for the instance's name. And you can use the input the same way as for the other resources, like this. Let's take a look at the other values here. We're currently using some statically configured infrastructure resources, but we can make Aria Automation choose them dynamically for us based on our configurations in the Infrastructure tab. As you probably already know from existing Aria automation features, we call this selection process allocation, and we call the things that it selects placement targets. Let's see what I have in the project of my cloud template. I have added 3 cloud zones, one for AWS account in US West 1 region, one for GCP and Europe West 1, and one for AWS and US East 1. So the allocation will choose from these 3 cloud zones for me, and will select placement targets in the chosen account and region of the zone. Let's go back to the cloud template and see how we can leverage the new generic allocation feature. We have these new allocation helpers for this purpose. Before I proceed, I want to highlight that we don't need to use them for every cloud resource we deploy. As we already saw, we successfully created an instance without using any allocation helpers. Their purpose is to help you when you need it, and you can skip them in all other situations. Use them only if you have use cases in which you need Aria automation to select placement targets for you. So if you do, continue watching to see how. Let's begin with the compute allocation. We can easily understand how we can use this helper if we click on its properties. There is a completed column which marks whether each property is used as an input or as an output of the allocation. The properties which don't have a check mark in this column are the input properties, the ones we use to define our criteria for selection. In case of the compute allocation helper, these are the account type, constraints, count, and group ID properties. The rest have a check mark in this column, so they are the computed, or in other words, the output properties. We use them in the values of the properties of our cloud resources to configure them dynamically. The properties also have some description. For example, let's click on the first one. We see here that this is the type of the cloud account, AWS, Azure, GCP, etc. These descriptions can also help you find out what property you need. Since the compute allocation is used to select the compute, let me show you what computes I have in the infrastructure tab. You can see I have some computes in the GCP account, some in the AWS account in the US East 1 region, and some in the US West 1 region. Let's say I want the location to select a compute based on some tag. For example, NDEF. You can easily see the only compute which matches this criteria is US East 1A. So how can I do that? Let's go back to the cloud template and see. Let's see the properties again. Account type doesn't sound like what we need. Constraint sounds like the right thing, and if you have used Aria Automation's resource-specific allocation, I mean the one we had even before the new plugin model, it should sound familiar. If I click on it, I can see that the description says, to target the correct resources, blueprint constraints are matched against infrastructure capability tags. So this sounds like exactly what we need. So I'll use it. I'll specify NDEF tag like this. So I expect that the allocation will select US East 1A. If I check the properties again, I see that the compute allocation also allows me to use the selected cloud account and region, so I'll use all of these to configure my instance. Let's start from the region. How do I know what to write here? There is an easy way to do it actually. Let's open the properties of the helper again, click on the selected region, and I can click on this icon that appears next to the ID to copy the full path to the ID, meaning exactly the value I need to paste for region. Easy, right? So let's do the same for the account and availability zone. I need the name of the cloud account, and the ID of the placement compute. Okay, we're ready to create a new version of our cloud template. Before I deploy it, I want to explicitly say that I don't need to use input properties in the location helper if none of them are required. If I delete these constraints, then this is still a valid cloud template, and the location will select any of the suitable placement computes, and it will be used for the instance creation. But in my case, I want to select only from the computes with this specific tag. So let's deploy this. While we're waiting for this to get deployed, I want to show you a simplified diagram of what the location for this deployment looks like. This box represents the compute allocation helper from my cloud template. We set the constraints to ndev, and by default, this is considered a hard constraint. As for the resource-specific allocation we had before the new plugin model. You might be surprised to see that we have another property here, account type, but we haven't added this property in the cloud template. So why have I added it here? This is an optimization we make. Let's go back to the cloud template for a second so that I can explain it. You see that we have this AWS resource, which depends directly on the location helper. So the location should select placement targets only from AWS. The other ones won't work for this cloud resource. So if you as a user don't specify an account type, Aria Automation automatically adds it for you based on the dependent resources. So this is why in our compute location helper, we have the location type set to AWS. We saw this project in my environment. It had 3 zones, so let's consider them one by one as the location would. The first zone is in AWS and US West 1. It has 2 computes, US West 1A and US West 1C. The first compute has the end-test tag, so it won't be selected because it doesn't match the end-dev constraint. The other compute doesn't have any tags, so it will also be discarded because of the hard constraint. The next zone is in GCP, which means we don't even consider its computes because of the mismatch of the account type. The third zone is in AWS and US East 1. It has a lot of computes, but for simplicity, I have depicted only the one with the end-dev tag. The others won't be selected for the same reason the US West 1 computes weren't selected. So, as a result, we have a successful configuration. The selected cloud account would be AWS, the region would be US East 1, and the placement compute US East 1A. So let's check what happened with our deployment. It's successful. If we click on the compute location helper, we can find the selected placement targets in the output section. The selected cloud account is truly AWS, the selected region is US East 1, and the selected placement compute is US East 1A, as we expected. If we click on our instance, you can see that the account, region, and availability zone are configured based on the results from the compute allocation. Okay, this was also not that difficult to do or hard to understand, right? If you have experience with Aria Automation's resource-specific allocation, the allocation flow for this deployment probably looks like a piece of cake, and you're eager to see something more. So let's see how we can leverage some of the other allocation helpers to configure more of our instance properties dynamically. Okay, let's say I want Aria Automation to choose instance type and image ID for my instance based on my flavor and image mappings. I can use the flavor and image helper to do that. So let's drag and drop a flavor helper here. The flavor property automatically appeared for my helper because it's a required property. And if I click on it, I can see that the description is the name of the flavor mapping to look for. So let's see what flavor mappings I have. I have large and small, so let's open small, for example. It is mapped to different flavors for each account and region from my project. So let's go back to the cloud template. And as you can see, we have autocomplete for this property. So it's easy to select the flavor name from the ones we have defined in the infrastructure tab. Let's choose more, for example. So how can I use the selected value for my instance? Let's open the properties again. And I can see I have this selected instance type name. It looks like this is what I need, so I'll copy it and paste it as the instance type value. That's it. Now, you might start to get frustrated with the fact that you already have 2 additional resources in your cloud template just to configure some properties of your instance. And I think this is a normal initial reaction, but you'll begin to see and cherish how powerful these new allocation helpers are in time. The biggest benefit you get from them being separate resources is you can use them to configure any kind of resource you need and any property you want. Imagine the flexibility this gives you. As soon as a new resource type appears in Aria Automation, you can start using allocation for it without waiting for a new release of the product to include support for allocation for this specific new resource type. And if you have some very specific use case in which you need to use a selected placement target in an unusual way, you can just refer the selected value anywhere in your resource without you having to write any custom logic. So in the beginning, when you're getting to know the new capabilities, you might be overwhelmed and think this is unnecessarily complex, but I'm sure you'll get the hang of it, maybe even until the end of this tutorial, and start to appreciate the power of the allocation helpers. I bet that very soon you'll even want Aria Automation to introduce even more allocation helpers. Now, I hope that you gained some courage and you're ready for us to add one more allocation helper to this cloud template. The image allocation is very similar to the flavor allocation. The image property holds the name of the image mapping to look for. Let's quickly check my image mappings. I have Ubuntu and Windows, so let's open Ubuntu. It maps to different images for each account and region combination from my project. Let's go back and choose Ubuntu. And I'll do the same trick to copy the selected image ID and use it in my cloud resource. And we're ready to create our third version of the cloud template and deploy it. Okay, while we are waiting, let's have a look at a similar diagram to the one we saw for the previous deployment, depicting the allocation flow for this deployment. You see that our 3 allocation helpers are grouped together. Why is that? Let's go back to the cloud template for a second. The instance directly depends on all 3 allocation helpers. In such cases, the allocation engine infers that they should be considered together. But what does that mean? As I said before, each allocation helper chooses placement targets. Each placement target is in a specific cloud account and region. So if 2 or more allocation helpers are grouped together, this means that all the placement targets selected by them are in the same account and region. And if there is some affinity between different placement targets in the group, for example, an image is stacked to match only specific computes, this will also be taken into account. All we know, the allocation will choose placement targets for each helper in the group that work together. And if the same resource is configured with more than one allocation helper, it's clear that the placement targets for all these helpers should work together. So the allocation engine makes your life easier and groups them together. The compute allocation is the same as in the previous diagram. We haven't changed this helper in our cloud template. The flavor and image allocation have the name of the mapping to look for, and account type for the same reason as the compute allocation. The dependent resource is an AWS resource. The project, zones, and computes part of the diagram is the same as before. Then, based on the flavor allocation helper, we look for a suitable flavor. The flavor mapping for large doesn't fulfill the criteria of the helper, so it's discarded. The flavor mapping for small matches the flavor property of the helper, and we have a flavor for the account and region chosen by the compute location, so T2 small would be selected. The other ones don't work together with the selected compute because they are in a different zone, so they won't be selected. Similarly, the location won't choose image mapping for Windows because we have Ubuntu in the image helper. And it will select the image for AWS and US East 1 because of the compute allocation. So as a result, we should have a successful configuration, the same as in the previous deployment, plus a selected instance type and image ID. Let's see what happened with our deployment. Great, it's successful. So let's check the outputs of the flavor allocation. We can see the selected instance type is T2 small in the AWS account and US East 1 region, as we expected. And in the outputs of the image allocation, we can copy the selected image ID, go to our image mappings, and we will see it's the same as the one for Ubuntu in AWS and US East 1. Let's check our instance too. It has the proper image ID and the proper instance type. So we have successfully configured it with the location helpers. So the last thing I would like to use a location for is the subnet ID of my instance. I can use the network allocation helper for this. I would like to choose an existing network for my instance, so I will leave this network type existing by default. If there is at least one network profile for the region considered by the allocation engine, a network profile would be selected, and a network would be chosen from the ones added in the selected profile. If there are no network profiles for the currently considered region, a network would be selected from all networks in the region. In my case, I have network profiles for the region that would be selected by the compute allocation. So let's check them out. I have one for GCP and two for AWS, both of which are in US East 1. The network profile with default network has this default net tag, and the other one has this alternative net tag. I have added different networks in the two profiles. Here I have a subnet, which is default for the zone. And in this one, the subnet is not default for the zone. So it does matter which one the location will choose. Let's say my use case is that I want the network profile to be chosen based on a specific tag. For example, this one. So let's go back to the cloud template and see how to do that. Similarly to the compute allocation, I can leverage the constraints property for this purpose. The autocomplete will make my life easier again. And the same way I did it with the other locations, I'll copy the selected subnet ID and paste it here to configure my instance. It's really easy to do it with this copy icon. So in very little time, we have the subnet configured dynamically, and we are ready to create the next version for our cloud template. Let's deploy it. And while we are waiting, I can show you the allocation flow for this particular deployment. It will be quite similar to the previous one, just with network allocation added in the picture. Again, our helpers are grouped together because the instance depends on all of them directly. And the only new thing here is our network allocation helper, which has the network type and constraints properties we defined in the template, and the account type inferred from the fact that the dependent resource is an AWS resource. Then we have the project, zones, computes, flavor mappings, and image mappings, same as in the previous diagram. So let's get to the new part, selecting a network profile. The first one is in GCP account and will be easily discarded because its account type is GCP, not AWS. The one with the default network has the default net tag only and will also be discarded because of the alternative net constraint. And the last one is in AWS and US East 1 region and will be chosen because it fulfills our constraint and matches the account in region selected by the compute allocation. So this would be the selected subnet. And the selected configuration looks the same as in the previous deployment, but we also have a selected subnet. Let's go back to our automation and check our deployment. It's successful, so let's check the network allocation outputs. We have the selected subnet here, and we have other things from it we can use besides ID. We have the net mask, the CIDR, and the prefix length. Let's copy the subnet ID and make sure it's the one in the network profile with the alternative net tag. This was the one. Okay, it's the same. So let's check our instance subnet too. Yes, our instance is connected to the right subnet. And if we go back to the network allocation outputs, we can see that there are other useful things we can reference in our cloud resources. The selected network domain, which in case of AWS is the VPC in which the subnet resides, the selected security groups, which in my case are the Cell Manager security group and the default one. The selected security groups are the ones from the selected network profile. Let me show you. I have added them to my network profile here in the security groups tab. Let me highlight again the benefits of dynamic configuration. Let's quickly go back to the first version of the cloud template. As I said previously, you don't need to use allocation. We have a perfectly valid AWS instance here without any allocation. But what if you have a lot of cloud templates and you have a lot of such instances across all templates, which let's say should be connected to the same network? And one day your team needs to discontinue the usage of this network, so the admin creates a new network and all of your instances deployed in the future should be connected to this new network. You can do that, of course, just by switching to the ID of the new subnet here. But you will need to do that in every single cloud template and every single instance. In contrast, when using allocation, switching to the new network will be very easy. The admin can just go to the network profile and switch to the new network. Let's see how that would work. I'll just open my network profile, add the new network. Let's say I want to switch to this dual stack subnet. And I'll just remove the old subnet and save the changes. Now let's go back to my cloud template. Since I'm using the network allocation helper here for configuring my instances subnet, I don't need to change this cloud template at all. All my cloud templates which leverage the allocation mechanism and all catalog items published from them will start working with the new subnet out of the box. No need to touch any of them. And we considered only the subnet configuration, but this applies to all other dynamic configurations. Let's take a look at another use case in which the location will help us a lot. Let's say we want to upgrade to a new Ubuntu version. In case we are statically configuring the image of our instances, this will cause some trouble. Same as for the subnet, we have to go and update the property value in all necessary places. But in case we are using collocation, the only thing that needs to be done is update the image mapping. So let's do that. I'll open my Ubuntu image mapping and update the value for US East 1 region in the AWS Cloud Count. Let's say I want to upgrade to this Ubuntu version. So I click Save, and that's it. No changes in my cloud template are required. So let's go ahead and deploy this to see if the new instance will have the new image and subnet. Okay, it's ready. So let's check the chosen image first. I'll copy it to make sure it's the one from the image mapping. Yep, it's the same. And it's the one used for the instance. And now the selected subnet. Yes, it's the dual stack subnet that we used in the network profile. So I'll just quickly copy its ID to show you it is the one used for the instance. Right, so we successfully upgraded to a new Ubuntu version and to a new subnet without changing anything in the cloud template. We only updated the image mapping and the network profile. So if you're just beginning to use Aria Automation, static configuration would be enough, but consider leveraging the location mechanism in the long run. It will certainly make your life easier in the future. Okay, we have an instance here configured with these 4 location helpers. The next thing I would like to demonstrate is that we can reuse the same allocation helpers to configure another instance. We don't need to create a separate allocation helper for each cloud resource if we want to use the same placement target selected by the helper. So let's add another AWS instance with a different name. So let's create another input for its name. And I want it to be created in the same availability zone and with the same flavor and image and subnet as the first instance. So you can see both instances are referring to the same location helpers. No problem to do this. And I want to highlight that you can reuse a helper not only for a cloud resource from the same resource type, but for a resource from a different type. For example, I'm going to add one of the other new plugin-based resources we have, an AWS volume. I'll add another cloud template input for its name. And use it here. And let's say I want to attach this volume to one of my instances. So I need to create it in the same account, region, and availability zone as my instance. So let's copy these values from the instance. And you can see how I reused the compute location helper to configure my volume. Let me configure more things for my volume. The size, the type, and IOs. Okay, so how can I attach it to my instance? Let's check the instance properties. Aha, these block device mappings should do the trick. Let's refer to the ID of the volume here. We already saw that the resources from the new plugin-based AWS resource types have this resource ID property, which we can use for this purpose. And I also need to configure the device name because it's a required property. That's it. Let's create a new version and deploy this cloud template. We have 3 cloud resources to deploy here, so this will take some time. Let's fast forward until it's done. Good, we have all of our resources now. Let's check where they landed. The first instance is in AWS and US East 1 region and US East 1A availability zone, as in the previous deployments. And the other instance is also there. And the volume landed in the same place, so all 3 were configured by the compute location helper. If we check the properties of our instance, we can see it will have the same flavor, image, and subnet as the other one. For example, the instance type is T2 small, as for the other instance. So for the last portion of our cloud template, I want to emphasize that the location helpers are generic, and they can be used not only for the new plugin-based resources, but also for the other resources we had in the product before this new feature. For example, you can use them for the cloud provider-specific resources that don't support resource-specific allocation. In my case, I want to encrypt my volume with a new KMS key, which is an AWS-specific resource we had in the product even before this new feature, and it couldn't be configured dynamically before. Now we can use the location helpers to do it. And this would be just one example. You can use it for other resource types, even for custom resource types if you need to, or any new resource type that appears in the future. Okay, let's add the KMS key. Since in my scenario I want to encrypt the volume with the key, for this to work, I need to create it in the same account and region as the volume. So again, I'll reuse the compute location helper to configure my KMS key. I'll just copy the region and account from the volume and paste it under my key. Let's see how to use the key for the volume's encryption. I'll look into the volume properties. Okay, we have this encrypted property and this KMS key ID property. So this should work for this use case. Let's add the encrypted property. And let's refer the ID of the KMS key we just created here. And that's it. Now all of my cloud resources will be created in the same place. Let's create the last version of our cloud template and deploy. Again, this deployment will take some time, so let's fast forward until it's completed. Okay, we have our last deployment successfully created. We can check our KMS key to see that it also landed on AWS and US East 1. Let's see. The account is AWS and the region is US East 1. And if we copy its ID, we can verify it was used to encrypt the volume. Yes, that's the right key. Perfect. All of our cloud resources, from the new resource types and from the ones we had before this new feature, were configured dynamically with the new location helpers. So the last thing I wanted to mention that you might have a use case for is user-defined grouping of the location helpers. If we check our location helpers in this deployment, we see that all of them have this group ID property and it has the same value. We already know why from the location diagrams we saw. The location engine grouped them together automatically, so it calculated a group ID and set it to all of them. But what if we have a use case in which we need to group the helpers in a specific way? We can group them however we like to fit into our use case by adding the group ID property to each helper. Let me quickly show you how. Let's say I want the compute and flavor helper in one group and the image and network helper in another one. I can add group ID 1 to the compute helper, group ID 1 to the flavor helper, group ID 2 to the image helper, and group ID 2 to the network helper. So if you need something specific, you can do it in this very easy and flexible way. Okay, we evolved this cloud template a lot of times, so let's go over each version again to summarize what we did in this tutorial. We started with one of our new plugin-based resources, a basic AWS instance with statically configured properties. This cloud template was quite small and really simple to create. I didn't even need any configurations in the infrastructure tab other than an AWS account and a project. Then we gradually added allocation helpers to make Aria Automation choose the configurations we need for the instance dynamically. We started small, only with compute allocation helper, which we used to configure the account, region, and availability zone of our instance. Then we added flavor and image allocation helpers to set the instance type and image ID of our instance. And the last allocation helper we used was the network helper, which we used to define the subnet ID. Then we added a second instance that is configured with the same 4 allocation helpers as the previous one. We also use the compute allocation to set the account region and availability zone of an AWS volume, also from the new plugin-based resources. And we attached it to one of our instances. Finally, we decided we want to encrypt the volume with a KMS key, and we used one of our AWS-specific resource types, which existed even before this new feature. We saw we could successfully use the same compute allocation helper for the KMS key, which was an example that the allocation helpers can be used for any resource type and are a very flexible and powerful way to support allocation for all kinds of resources, even for the ones that will come in the future. You probably noticed this blue information box throughout the demo. We see it because we have a plugin-based AWS instance, a plugin-based AWS volume, and allocation helpers in our cloud template. All the new plugin-based resource types and allocation helpers are beta features at the time I'm recording this tutorial. And this is not because we have implemented some quick and dirty solution to provide this for you. It's just that we want to get your feedback as soon as possible, and these new resource types might need to be changed. For example, if you have some cloud templates with the new types, you might need to change them a bit in some subsequent release. This is not something we're sure that will happen, but it is possible. If you click here, this will open the documentation and you can find more information about these new resource types. And I want to reiterate once again on the value of the new features we saw. Each public cloud provider has their own specific resources and special features for each resource, and we want to give you more of this flexibility with the new plugin model. We also acknowledge that the public cloud providers also introduce new features, and the new plugin model will help us provide them for you in Aria Automation faster. And we want to allow you to dynamically configure your resources from the new types, so we're introducing this new generic allocation mechanism so that you can apply it wherever you need. During this tutorial, I gave you just a taste of the new capabilities. I used a plugin-based AWS instance and a plugin-based AWS volume. But you can expect many more plugin-based resources to appear in the future and more public cloud providers, not only AWS. I also used compute, flavor, image, and network allocation helpers, but we'll continue adding more to help you select different types of placement targets. More features might also come in the future, like out-of-band support, meaning giving you the ability to work with newer or older version of some plugin without needing to change your Aria Automation version. Thank you for watching this tutorial. I hope it was useful for you and that you now feel ready and fully equipped to start using the new features, including the new plugin-based resources and the allocation helpers. And if you want to just copy and paste one of the versions of the cloud template I created as part of this tutorial and tweak it for your use case and evolve it more, you can find links in the description. Enjoy!